PGEtinker, aka I finally did something cool. For those who aren't aware, PGEtinker is a web application I made that allows you to make OLC Pixel game engine programs written in C++ within the browser. Disclaimer. This presentation is not intended to represent what may or may not be considered best practices in web development or in system administration. The author, that's me, accepts no responsibility whatsoever should you try to copy the methodology demonstrated herein. Basically, don't do it. But if you do, send pictures. This is PGEtinker at a glance. During this presentation, we're going to address each of these little boxes you see in turn and to varying levels of detail. We're going to start with PGEtinker Services Stack, which is a collection of 4 services that work together to provide the PGEtinker experience. The Services Stack, the main application, which uses Laravel and is also where the primary installation of Emscripten is located. The language server, which is responsible for providing things like code completion, type hinting, error reporting, and a few other features to the code editor. Whenever you share a code, a screenshot appears along the embedded link, and we get that screenshot using the screenshot service. And of course, the wiki, which currently is a work in progress, but it will eventually be the place where all of the help documentation is located. Here we're going to talk about the main application. The main application front end is developed using Vite, or however you want to pronounce that, using the usual suspects, HTML, CSS, JavaScript, and a little TypeScript. We use a library called Golden Layout. It's a library that provides the ability to do click and drag actions, docking, stacking, and it's basically the reason PGEtinker is so customizable. Monaco Editor is the code editor of PGEtinker. If you use Visual Studio Code and it looks familiar to you, that's because Monaco is the editor that VS Code uses. The Monaco language client is basically it's the client that interfaces between the editor and the language server, and we'll cover that later on, but basically it's how things like code completion and type hinting, error reporting, and all that stuff sort of works. On the subject of front-end frameworks, I don't use any. It's not because I have an innate dislike of the frameworks here, except for maybe Angular and React, but they all come with certain degree of mental overhead, and I prefer to just write my code in JavaScript and move on with my day. The backend, it serves the static front-end files as well as provides an API. This is done with Laravel. For those who are not aware, Laravel is a framework that is written in PHP. I chose it because of all of the web technology that exists today. I'm most familiar with PHP, and I love triggering people who think I should use C# or Rust. And of course, Emscripten, which is the C and C++ compiler that we use on the back end. Now let's talk about the language server. Language server is responsible for providing the front end with all of the things that LSP provides. It's built using Node.js, the Visual Studio Code language server, the Visual Studio Code WebSocket JSON RPC. We're noticing VS Code a lot here, guys, okay? ClangD, which is the actual language server, the thing that actually runs the compiler and provides information back. And here's where it looks, so here's where the language server fits in the big picture. The language client, which is a part of the main application that I talked about before, connects to the language server via a WebSocket. Now, I would love to give an in-depth talk about ClangD, but I'm just not qualified to give a deep dive on what ClangD does. But the basic idea is when you update the code, it runs the compiler and gives a bunch of diagnostics, which bubbles up the stack, and it ultimately manifests in a response via the WebSocket connection back to the client. A screenshot service. It's a simple Node.js application. It runs Puppeteer, which is basically Chrome, but automated, and it's responsible for attempting to take a screenshot. So when you want to share a code, it'll display a screenshot of your program as part of the embedded link. And here you can see some examples, Discord on the left and X, formerly Twitter, on the right. If for some reason the service fails to capture a screenshot, the assumption is that the code is at fault, and I use a scary graphic intended to warn a user that the code might be risky to run. The wiki, it's a documentation site that is generated using Hugo, which is a site compiler of sorts that allows you to write your page content in Markdown and then generates all of your site as static files. There's no backend, which means there's nothing to hack. And right now the documentation consists of a very lengthy credits page where I give thanks to pretty much everyone in every project that I can think of that had a hand in the success of PGEtinker. You should go ahead and give it a read sometime. Now that we have a basic understanding of the PGEtinker services stack, we can discuss the rest of the infrastructure from a higher level. I get asked what the inspiration is for the names. When I start a project, I pick a fandom or a theme, and that's how I derive names for things. In this case, the inspiration comes from a film that is known for being among the earliest to make heavy use of CGI. Released in 1982, the movie Tron. Each character's purpose in the movie has a related purpose within PGEtinker. Kevin, for instance, is the main character, and he's the whole machine. The pit was a place where programs were kept until they were put on display in the games. Ed was the asshole of the movie. Alan and Laura were supporting but pivotal characters. Walter's alter ego was a guardian of the input-output tower. I find it fitting that he is our load balancer. You'd be forgiven for assuming that PGEtinker runs on some cloud service like AWS or Azure, with some complex Kubernetes clustering and all of the web development buzzwords. Early in development, I did a price comparison for the resources that I would want to have in order to have a solid starting point for the project. I found that I could rent a bare metal server and provide the services to myself using Proxmox and virtual machines. Using AWS would cost 20 times more per month than the bare metal server costs me to rent. Given that PGEtinker is a hobby project, it exists on the generosity of a handful of amazing people who have chosen to support the project. Sort of have to be a penny pincher here, so that means that services like AWS and Azure are completely off the table. There's also this. Alrighty. So the internet and Cloudflare. We're going to sort of work our way from the outside and work our way in. The internet. The internet. Without it, we wouldn't even be having this presentation. But we don't control it. We don't have anything to say about it. It's just there. It exists, and it makes it all work. Cloudflare, on the other hand, gives us what they claim is privacy protecting, or privacy respecting, I should say, analytics. Now, I've chosen to use them because it appears to be far less invasive than some of the other choices I could mention. We also use Cloudflare for caching and DNS. The combination of these two services reduces load times for people who are accessing the website away from where the server is actually located, and overall, it does a pretty good job at it. Walter. Walter, in addition to the services that it provides, is the bridge between the internet and a virtual local network. This is done to isolate the application servers from direct exposure to the internet. We do this using Nginx, and it's used as a caching reverse proxy, and also functions as the load balancer between the applications hosted on Allen and LoRa. We'll talk about them later. Uh, Walter also hosts the database. We use Supabase. We also use Redis, which is really fast and great for caching. But the big win for using Redis is to cache the output from the compiler. Now, each code is run through a hashing algorithm, which serves as the key for the compiler results. And those are stored in Redis. And this helps us to mitigate things like high CPU usage if like a lot of people try to compile the same code. All right, and then deployment scripts, which allow me to quickly set up the staging environment so that I can test any of the changes that I've made. It's the same environment as the production environment, but it allows me to run the tests on it without interfering with the already running services. It also allows me to do rolling updates of the nodes behind the load balancer, keeping the services online publicly, even if a node behind it is brought down to perform an update. And we use Go Access to generate statistics pages based on Nginx's access logs. These statistics, coupled with the provided statistics from Cloudflare, give us a better idea of the shape of PGEtinker's traffic. All right, back to Allen and LoRa. Allen and LoRa, we have deployments of the PGEtinker services stack. This is done with Docker Compose. The main app has 4 instances, as does the language server, which means that at any given moment, there are 8 instances of the compiler ready to compile your code. The benefit of using Docker here is that we can control how much of a given container is allowed to use in terms of resources. Clang has this internal bug which would allow a relatively small snippet of C++ code to try to use 2 to the 64th times the size of the type of RAM during compile time. This happens in the compiler, so it affects the language server as well. Without CPU or memory constraints, this would crash Kevin outright. Now, I want to emphasize this for a moment. I didn't say that it would crash the instance. I didn't say that it crashed Allen or crashed LoRa. It crashed the entire machine. And I'd like to shout out for a moment Eightfold on the OLC Discord server for pointing this compiler bug out to me so that I could make PGEtinker more resilient to it. On Allen, there is another instance of the PGEtinker services stack, and that's where the staging environment is hosted. And there are also helper scripts, which are used during deployments that automate the staging process as well as the update process. The PIT. All right, the PIT is a self-contained file and image hosting service. It's used by the PGEtinker main application for screenshot hosting. So whenever you share something and it takes a screenshot, it's successful at taking a screenshot, it uploads it to the PIT and gets the URL back, and that's how we get the embedding for the shares. And it will also be the future home of the PGEtinker asset collection, which I need to sit down and get together with people, and we need to pick what graphics are going to be a part of that. All right, now we're going to talk about Ed. Ed is the testing environment. It is identical in terms of the operating system and software packages as Allen and LoRa, with the small exception that in order for our continuous integration to work, we need to have Chrome running to do our browser testing. It's also the self-hosted runner for GitHub Actions. And thanks for coming to my TED Talk. Congratulations, you've survived. And you can find me at these places. And if you'd like to support the project, I have a Patreon and a merch store if you want PGEtinker branded stuff. And I'm happy to take your questions at this point if you have any.
Just actually, I meant to ask you about importing external headers. Is that you sent me a message, right, just saying that you can link a header from a GitHub, but you would actually have a lot of problems. Is that right?
Okay, so
Yeah.
it's one of those situations where it technically works, but the language server is going to hate you every step of the way for it. Um, so I'm going to really quick here
Yeah.
um, actually demonstrate what I mean by that. Okay,
Oh, yeah.
so if we go define, oh, actually I don't have to do that. So I go here and we go include,
Mm-hmm.
and we do that. All right, and it says here file not found. This is because the language server isn't set up in any way to be able to support the remote stuff, but
Yeah.
I can run it.
Okay. Okay.
All right, and
Yeah.
to show what I'm looking at here, I'm I'm actually pulling it straight off of the PGEtinker repo. This is the example one.cpp,
Mm-hmm.
right?
Could you go back there a second? So did you? Oh, that was the raw. Yeah, I get you. I get you. I know what
Yes.
I did wrong. I know what I did wrong. Oh, yeah.
Let me
I'm an
guess.
idiot.
It was a URL thing, I guess.
No, I did put in. What did I think I did something. I did it wrong. I'm not going to embarrass myself in front of all these gurus that are here today,
Yeah.
Pirate and all these lads. They'll be all laughing at me later. Yeah. So
So
yeah. Mhm.
because of this, if you have something that's externally included that provides like functions and all that sort of stuff, you're going to go to use those functions, and you can see how the language server is going absolutely apeshit, right? Like,
Yes. 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 Mhm.
right?
Yeah.
Let's put this inside of a function. Void does nothing. All right, just to shut that part of it up, and then let's go int a b c equals 0 just to shut that part of it up, and then now look, see, undeclared
Undefined.
identifier. So like if we take it as, let's just trust me, bro, that this function actually exists in the included file, then this is the
Mm-hmm.
language server doing its job because it doesn't have a notion of what's in this file.
Yes. Yes.
So it degrades the experience using external files, but technically it works. Like you can click the run button and it will run. So
Okay.
let's see here. Were there other questions? I'm looking in here real quick. All right. Oh, so Moon President asks, I wonder if you could use other graphics libraries. So if this is one of those technically yes questions, right? Um, if it's something that is self-contained with what you include, absolutely you can. Emscripten and the way I currently build uh, allows you access to the SDL stuff, so you can use SDL. Like um, you could erase the code and put in an SDL application, and as long as you're using the stock SDL headers that would be included with Emscripten, then absolutely you could. It would be outside of the scope of what I intended to be used for, but you could. And I wouldn't, like the Pixel game engine has facilities to make it more friendly for the environment, for the page layout and all that stuff. So like there's
Mm-hmm.
some things that you wouldn't get by doing that unless you actually expressly wrote those functions.